G'day, Year 11. We're going to be looking at the differentiation of trig functions. In other words, if y equals sine of x, the derivative dy dx, and you've seen this before, is positive cos x. However, if y equals cos x, then the derivative of cos x is actually negative sine x. And that's the basis for our trigonometric differentiation. Now, just like all the others, we'll use variations of the chain rule, and let me do a few examples for you. So if y equals sine of 3x squared, dy dx will equal 6x cos 3x squared. Just like in logarithms, just like in um, exponentials, the angle stays the same. With logarithms, the log of what we're doing the log of stays the same. With exponentials, the power stays the same. We times by the differential of the power and of course change it through. Let me explain why using the chain rule. So I'm going to let y equal sine u. So dy du is simply cos u. But that means u equals 3x squared. So du dx equals 6x. So therefore, dy dx equals dy du times du dx. Okay, you should be experts on the chain rule. And so, of course, dy du is sine u, which is, of course, 3x squared, and du dx is 6x. And again, to write it in a different order, 6x sine 3x squared. Okay, there's the basis. I'll do a couple more. Okay, if the function is 3 cos of 6x squared plus 2x, the derivative, remember, the 3 is just a constant, it stays there. The derivative of inside the brackets is 12x plus 2. Okay, the derivative of 6x squared is 12x, derivative of 2x is 2. And of course, cos becomes negative sine of 6x squared plus 2x. Prettying it up a little bit, I might actually multiply the 3 into that bracket and make it 36x plus 6. Put a negative out in front, sine of 6x squared plus 2x. You'll note the angle has stayed the same. The differential of the angle went out in front. The constant stayed there. And of course, when we differentiated cos, it became negative sine. So that's it. I'll just do one more. Why not? F of x, and you can turn it off if you've already had enough. And I'll just do, what about 5 sine of 3e to the x. Ooh, what's that going to end up? Let's have a look. Try to be a bit tricky here. The derivative, so 5 stays there. The derivative of 3e to the x is actually 3e to the x. So that stays there. The derivative of sine is cos, positive cos, and of course the angle stays the same. And so we get 15e to the x cos 3e to the x. So we've actually done a chain rule within a chain rule. And that wasn't hard. Enjoy.